welcome to my YouTube channel Medical Imaging Tech. So, today I'll be taking a presentation about electromagnetic radiation. So, this forms the base of radiation physics subject in the field of radiography. So, let's look at the contents. I'll be giving a brief introduction. Then we'll be discussing about some common properties of electromagnetic radiation. Then we'll also see what is an electromagnetic spectrum and its various properties. So what is electromagnetic radiation? Electromagnetic radiation, it is a transport of the energy through space. Okay, so electromagnetic radiation will be in the combination of two fields, that is as a combination of electric field and as a combination of magnetic field. That is why the name is called as electromagnet. So let's look at how electromagnetic radiation is represented. So as you can see in this picture, electromagnetic radiation is represented as a combination of electric field and magnetic field. You can see that in this figure, the electric field and the magnetic field are perpendicular to each other to the direction of the propagation of this wave. So this is how the electromagnetic radiation moves. This is a path. That's why it's called the direction of propagation, and the electric field and the magnetic field will be perpendicular to the direction of propagation. Now, electromagnetic radiation have dual nature. Dual means two types of nature. It can behave as a wave. It can also behave as particle. So let's look at what is this wave concept of electromagnetic radiation. So as you all know, as I've already told, electromagnetic radiation, it will propagate or it will move through space in the form of waves. Okay. So I already told there are two types of concepts like wave concept and particle concept. So according to wave concept, they say that the electromagnetic radiation passes or moves through the space in the form of waves like this with some velocity. They do not require any kind of a medium like a solid or a liquid medium to travel. They can also propagate and move through vacuum. And as I have already told, the electric field and the magnetic field are perpendicular. So let's see what all factors depends on this electromagnetic energy. So we have the first factor, amplitude. It is written as capital letter A. So amplitude is defined as the height of a wave. Okay, so this is the amplitude. This is the height of the wave. Next we have wavelength. Its symbol is called as lambda. What is wavelength? Wavelength is the distance between two successive crest or trough. So crest is the top part of a wave. Trough is the lowest part of a wave. So the distance between two, this is one crest, this is a second crest. So the distance between two crests is called as wavelength. It is written as lambda. Then you have one more term, frequency. The unit is called as nu. The symbol is represented like this. It's this frequency. So frequency is the number of oscillations of the wave per second. Okay, so per second, how much of oscillations the wave has is called as frequency. So let's look at a very important electromagnetic wave equation. So the wave equation is represented like this. C is equal to nu lambda, or nu is equal to C by lambda. So in the previous slide, we have seen all these factors We saw wavelength written as lambda, we saw frequency represented by nu, and velocity represented as c. So velocity is velocity of the electromagnetic radiation. So when you combine all these three factors, you can create a wave equation that is written in this way. Um, the electromagnetic radiation, it will travel through space or vacuum with the speed of 3 into 10 raised to 8 meter per second. And as you can see, frequency of the radiation is just inversely proportional to lambda. Whereas frequency and velocity is directly proportional, frequency and wavelength is inversely proportional. So particle concept of electromagnetic radiation, this is the next concept. We already saw the wave concept, so we'll move on to the particle concept. So, short electromagnetic waves like X-rays or infrared rays, they all react with matter as if they are like small particles than waves. So, they can be as a wave, also they can be like a particle. When it is in the particle form, we call them as photons. So photons, they are like very small bundle of energies. They can also travel at the speed of the light with varying electric and magnetic field. So basically, electromagnetic radiation has two concepts. It can exist as a wave. It can also exist as a photon. So I was talking about the photon. So we have an equation for calculating the energy of each photon or bundle of energies. So this is the equation. Photon energy is equal to h nu. H, I think some people might be familiar with these terms. So let's see what are these terms. Energy is the photon's energy, E. H is Planck's constant. It is the constant value 6.62 into 10 raised to minus 34 joule per second. Nu is frequency. So we can calculate the energy of the photon as h into nu, Planck's constant into frequency. Or you can also write energy of the photon equals h into c by lambda. So if you remember, just in the previous slide I had already told nu is equal to c by lambda equation. So in the place of nu you can substitute c by lambda. So the equation becomes E is equal to h into c by lambda. So now let's go on to the next part, that is electromagnetic spectrum. So this is how you define a spectrum. Spectrum is an orderly arrangement of electromagnetic radiations according to their wavelength or according to their frequency. So there are like several examples of electromagnetic radiations. You can, when you arrange them all in a manner, that is according to their wavelength or according to their frequency, you can call them as electromagnetic spectrum. Some of the examples of electromagnetic radiation are these. So we have gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves and radio waves. So we make use of X-rays, radio waves in our radiation field. So when you arrange them according to the wavelength or according to the frequency, you can consider it as an electromagnet. So here I present you the electromagnetic spectrum. So you can see that each of the rays are represented, like here you can see the gamma rays, then we have the X-rays, then we have the UV rays, then in middle here we have the visible light, that's what we can see with our eyes, then we have infrared rays, then there are radio waves. So there are different types of electromagnetic radiations which are arranged according to their wavelength. So top, if you see, you can see increasing wavelength in this direction. So that means which among these waves have the longest wavelength? Radio waves. Radio waves will be having the longest wavelength. Which one will be having the shortest wavelength? It will be the gamma rays. So that is how you arrange according to their wavelength. According to the energy also it is written on top. You can see it is exactly opposite. That is, radio waves have less energy. Which one has more energy? Gamma rays. Gamma rays have more energy. Here below you can see the wavelength of the visible light spectrum, 400 nanometers to. So here again I have represented the electromagnetic spectrum. Gamma rays, X-rays, UV, visible light, infrared rays, microwave and radio waves. And here you can see the wavelength. So you can see which one has the longest wavelength. The longest wavelength is for the radio waves, whereas frequency is low for radio waves and it is high for gamma rays. Wavelength is shorter for gamma rays. So let's look at the properties of gamma rays which have the highest energy. That's why it's written it's the most energetic radiation. And how it is emitted? It is emitted by radioactive disintegration. That's why it has very high energy. It is highly penetrating and it's also very harmful to living organisms. We can detect gamma rays with the help of using photographic plates or by using a device which is called as ionization chamber. So gamma rays are helpful for us also in the medical field. It is mainly used in studying the structures of atoms. Also, it's used in the field of nuclear medicine. So now we'll go on to the properties of X-rays. X-rays have a lot of properties, so we'll see some of them one by one. One is they are highly penetrating. They are invisible. We cannot see them using our eyes. Mainly it is used for diagnostic purposes. Then it is electrically neutral. That is, it doesn't have any particular energy. And it cannot be deflected by if you use electric or a magnetic field. Next property, it is heterogeneous. Means it has varying amount of energies. It has a wide span of wavelength or and energy. So you can see there is a useful wavelength range of X-ray. It can vary from zero point 0.1 to zero point 0.5 angstrom. So let's look at some other properties of X-rays. So when X-ray moves, X-rays can liberate small amounts of heat when it passes through matter. Then how does it travel? It travels in straight lines. At what speed the X-ray travels? X-ray can travel with the speed of light, same. That is 3 into 10 raised to 8 meter per second. Then they have a very unique property that is ionization. Ionization means it is the ability to remove orbital electrons, okay, from the atom. So X-rays basically have the ability to ionize gas. That is, they can remove the orbital electrons. So here we have the pictures of ionization and excitation. So in ionization picture, you can see that this is the X-ray photon. It will interact with one of the electron which is in the orbit and it has the ability to eject it out. Okay, eject it out of its orbit. That is called as a property of ionization. It also has a property of excitation. That is what happens is as soon as ionization happens, the one of the electron from a higher shell. So the shells are K, L, M, N like that. So one another electron which is present in the higher shell or the higher orbit will move towards the lower orbit, K shell. This is called as excitation. So these are two phenomena that happen simultaneously. After ionization, excitation happens. Continue with the properties. So X-rays also have the ability to affect the photographic film. Okay, so the film is affected by the presence of X-rays, and we develop this film later can by using some developing agents. It is done by using a chemical process. Then they can also produce X-rays can also produce chemical changes and biological changes in the body. That is by ionization excitation, which I already mentioned. This X-rays can also result in different radiation doses to different parts of the body. Radiation dose exposure it can affect internally and also it can affect externally. Then some parts in our body they are very sensitive to X-rays, especially the eyes, the orbits, gonads, that is the reproductive organs. They are very much sensitive to radiations like X-rays and gamma rays. So we have to always be very careful. We have to take the necessary radiation protection from the X-rays when we are going for a radiation exposure. So now we'll go on to one important property of X-ray that's called luminescence. So what is luminescence? Luminescence means when X-ray strikes on a particular substance, it emits light. That's called luminescence. If that emission of the light, if it lasts long as the radiation exposure, it is called as fluorescence. Whereas if the light emission, if it lasts for some more time than after the radiation exposure, it is called as phosphorescence. It's also called as afterglow. These are some radiation effects that has happened. So the one first picture you can see the person is having a hair loss after if you get a continuous exposure of radiation throughout your lifespan, then you may have such effects. Otherwise, it doesn't happen much. Then you can also have a genetic effects. You might be born with congenital anomalies because of the exposure to radiation. So now we are done with the properties of X-rays. Let's look at the properties of ultraviolet rays. Ultraviolet rays are also emitted by atoms or molecules. They can produce luminescence exactly as that of X-rays. Then they also can produce photoelectric effect. So this effect I'll be discussing later in another video. Photoelectric effect is also produced in X-rays. What are some of the uses of UV rays? It can be used to sterilize medical equipments, devices, water, food, etc. What are the properties of visible light? So visible light is something that we can see using our eyes because they consist of wavelength from 400 nanometers to 700 nanometers, violet, yellow, green, blue. You can see all these colors. They are also produced by excitation atoms and molecules. They can also travel in. Next are the properties of infrared radiation. So they can hear again they are produced by excitation of atoms and molecules. They can heat any substance on which it shines and it is not absorbed by air. What are the uses? It can be used in night vision goggles, in night vision cameras, in treatment of paralysis, skin diseases. You can also see the structure of molecules with the help of infrared radiation. Next, we have the properties of radio waves. They covers a considerable portion of the electromagnetic spectrum. They have very low energy, but the wavelength is very long. Where they are used in MRI. MRI is magnetic resonance imaging. So I'll be doing videos on MRI later. And radio waves can also be used for communication purposes. Now we'll move on to see the properties of microwaves. Microwaves have again long wavelength and lower frequency. It is used in communication and it's used in our household item, that is a microwave device. So here I have a table showing all the electromagnetic spectrum on one side, their wavelengths, their frequencies, their energies are written. So you can go through this table. So please don't forget to like, share and subscribe to this videos. So I'll be putting more number of videos in the future. And thanks a lot. Thank you so much.